For 2018, most of the improvements have been fairly small tweaks to improve different operating modes or different things that are giving me trouble. And the first of these is how to deal with my rod once I get something fouled on the tip, or I get the dropper wrapped around the bumper and that needs to be worked on. And before, I just kind of balance the butt of my rod on the bow of the boat, and this year I decided to make something a little more secure and took a Yak Attack roto grip and mounted it on a riser that nicely supports the rod when I need to work on it. This year I've started 3D printing as many parts as I can, so I don't have to purchase things that are generally more expensive than they need to be, or you just can't get one or the other. So previous years I would have used ram mounts parts to do all this stuff here, and this year I just printed this one part that's basically as long as I can print something given the size of my printer bed. And it's all one piece. It's got a pushed out area, rectangular area here that fits into the slot of the track to keep it aligned properly, and then just a T-bolt on the inside mounted there, and then on the back side where you can't see, there's a slot for a nut to slide in, and then it pulls up into a hex cavity to screw onto the rotor grip. Right next to it is this part, which I also 3D printed. This is a GPS antenna that is designed to mount onto a car roof, so it has a little magnet in its base. And so I did two things to keep it held here. One is I did a really tight fit on the perimeter, and then underneath this fairly thin surface I embedded a 1-inch piece of steel, about an 1/8 inch thick. And so the magnet's also doing work for me there. And then I made a little cable guide here to kind of keep things in their proper place. And since I didn't have much room in this piece here with the navigation lights, that's why I kind of built a little, went up in the air and then ran it forward to get it to fit properly. Then on the other side I'll move the camera around, and you can see the kind of the biggest project of the year. So here is a camera housing. Last year I just had the camera mounted exposed in this position, and the two issues with that is when it was getting splashed all the time, especially water on the lens, and I was trying to cut down on the amount of water, especially when I'm driving into a mist. This lens shield kind of cuts that out. And secondly, there's an electrical connection here, which I was always worried about. Even though I had a little cover for it, cloth cover, I was always worried about water splashing up inside of there when I hit a wave. So I've addressed both those issues, and then the third one being is that this camera is being in the bow of the boat. I can't reach it while I'm in the cockpit, and these cameras have a little thumb switch that's in this position here to turn themselves on. So last year I had to turn it on when I left, and a lot of times I'd be traveling for a couple hours before I actually use it. So that was a waste of power. Or I'd forget to turn it on and have to stop somewhere and get out and turn it on because I'd forgotten. So this year I designed this housing with this big paddle on it so that I can just hit the paddle with, or hit this paddle with my paddle, or a rod or anything, and I don't know if you can hear that, the little beep sound, but that was it turning on. And so this way it turns on, and I don't have to worry about having to get out and turn it on. And since I successfully did the holder on the other side, I also did the same thing on this side. In this case I needed more height than I could print as one piece, so I actually did it in two sections. And made a little joint here that's kind of a W, has a couple slots that mate, and then this screw that holds it all together. And so basically what I've done with all this section here is I've replaced all this RAM stuff that I had last year. So basically here's the equivalent of the two items. I did keep the one clamp here to adjust, so I could adjust things, fine-tune things. And in my case, where I mounted to my camera housing, I used a GoPro mount because it's much easier to print that than to directly print a ball as one operation. So I did that as two pieces. There are actually 9 pieces in all in this printed housing. As I move around to the back side, you can see that the cable's very snugly in there. And then I have a back cap that has a slot in it also that mates the two. And then I have a little pin that goes through the side that, and then I put a little clasp on through the hole there that keeps everything firmly in place. So that gives me a real tight seal all 360 degrees around that cable, so it's pretty hard for water without being pressurized to work its way up inside there. Another improvement was on this rod holder. I'm trolling with a rod going off diagonally in front of my body. I like using a ball mount rod holder versus something like a Scotty that's rigid, because I want the rod holder to take some of the force of the fish hitting the rod or hitting the lure, because since I'm running braid with very little stretch to it, and a fairly inexpensive rod that doesn't have a real sensitive tip, I expect the rod holder to do some of the work for me. So when I get a hit, the rod holder actually does move. Actually, when I hit a strike, the rod holder rotates. But the negative of that looseness is that last year it could easily, I'm going to go the wrong direction, but it could go way down, so the rod was way too low to the deck, and that was always a nuisance because I was always having to correct that. So for this year, what I've done is replace the factory part, which is right here, with a 3D printed part where I've extended this base so it goes quite a bit lower and also over to the side, so that now that extended base keeps it from coming any far forward than what I'm showing here. So before it could have, if I rotate around the other side, it could have gone down like this, and now it can only go to there. So that takes care of it dropping down lower than I want. This part was printed in a material called ASA, which is both UV stable and has extremely high tensile strength. So it should stand up to wear and tear over the year, but that remains to be seen, and I'm still carrying this original part, so in case this part does break during the year, I can replace it on the spot and still be able to fish. Right to the side of that is a place to store my fish grip. So I've made this holster that mounts to the track that's down here, and since I was using that mounting point with a ball on it originally, I built the holster big enough to mount a ball on top, so I can still use that mount point. And then my fish grip's attached to a lanyard, so it can be pulled away when I grab the fish. So it's a little tight here, but it does keep it out of the way. Last year it was just kind of laying here and being knocked around while I was moving stuff. Right in the center of my dashboard, I've built and 3D printed a new tool board. This one has slots that actually fit the tools I'm using, like the scissors, place for lanyards. This hole here is where my leg of my support for my tarp goes, and then this is a carrying handle when I'm picking up the whole toolboard or whole dashboard and carrying it to and from the boat. And then underneath there's a little this little orange thing is a place to store the micro USB cable for charging my phone. And then there are a couple other little odds and ends that I printed, covers for exposed screws, one here, one on this side, and one on the other side, which the little tab here on the other side I actually being used to hold cables down in place. This next item is a fix on one of the nuisances from last year, which was my camera mast here for my over-the-shoulder camera. I need to fold it down at night to put the tarp on. And last year I had this ram mount stuff that with all these degrees of freedom, every time you loosen this up to rotate it down, you'd have to realign the camera because everything moves so freely. So what I did is I replaced that with a mount that only has 1 degree of freedom, and it's just a simple hinge with a backstop on it, so you can lower it down for night, bring it up in the morning, and the camera's right back to its existing position. Not all parts have to be complicated. The very first part I designed on a 3D CAD system is a bushing that was replacing a plain steel bushing that I was never able to find in stainless, so every year I had to replace it because it was rusted. So both on the top up here and down below here is this bushing. Since I was 3D printing them, I could make them kind of the optimum thickness instead of just go with what I could buy. And these are printed out of nylon, and they're part of the axle for the steering mechanism. So nylon was a good choice for those parts. And to say it was the very first part that I designed, helped me learn the CAD tools, and also the first part I ever did print in nylon, which is not the easiest material to print with, but for something simple like this worked out real well. So one of the final projects was this wing for the motor boom. I was curious whether I could reduce the amount of turbulence that the round shaft was causing in the water as it got to the prop, and so I designed this wing to try to reduce that. I've taken video underwater and it's kind of still inconclusive, although I did find some other sources of turbulence that I fixed. I added some holes here in this debris fairing to cut down some turbulence that was creating the air. And I also found that this line on the bottom of the tilt mechanism would drag in the water and create quite a bit of turbulence. So I've added a bungee spring that keeps this line taut when the motor's in the down position, but also has enough springiness that if should I hit something, it still allows the motor to swing up to try to get out of keep the prop out of hitting the bottom or whatever you happen to be hitting. So I built this in 3 different parts that interlock together. The bottom piece has a surface that I designed to conform to the top surface of the motor, and that prevents things from rotating, and then the collar here is pushing down on everything to provide a little bit of pressure so it can't rotate easily without lifting up. And then I added a little bit of putty here on the front just so there was a tiny gap, maybe a 1/16 between my piece and the motor housing. And I didn't want that to be a place that would collect debris, so I used some duct seal, DUCT seal, which I wasn't sure if it would stay stuck here or not, but motor's been used about 20 hours with this on here, and it seems exactly the same as when I applied it, so it seems to be sticking quite well. So I'm not sure it's made a big improvement. It seems like it should be helping, and say my videos, they look better now than they did before, but not real conclusive. If you're wondering about this gap here, that's because this section fits inside of here, and if I built this out all the way to this length, then when the motor pivots, it would hit on this internal framework. And then see the back side, you can see it's a tapered wing on the back, and worked out actually pretty well. It was not too hard to design except for the surface here, getting that a nice tight fit. Took a little bit of trial and error, but not that much. I was able to measure things pretty accurately and come up with a a surface that adheres to it quite well. I've never had any issue with it rotating at all, so I'm quite happy with that. So here's my 3D printer starting to build one of my leader reels that I used to store my pre-made leaders that I make during the off-season. I have one reel for each length of leader that I make. And this printer is a Let's Bot Mini, which is considered a desktop mid-range machine. It has a build space of 6 inches by 6 inches by 6 inches and one extruder, which means you can only print one type of filament at a time. There are certainly cases where it's advantageous to have two extruders so you can print two different types of filament, either for aesthetics or, more importantly, for the kind of stuff I build, where you have overhangs or other places where you need to counter the force of gravity. Having two types of filament allows you to print using a filament that's dissolvable after the print is done. But since I don't have that, I have to work around that with either in the design or when I slice the design, I set up the slicer to print support structures. So this leader reel will take about 2 hours to print. It takes about 3.5 meters of filament to print it. And about midway through, I'll shoot another short video to see it midway and then again at the end. So here we are about 1 hour into the print job, and there's about an hour left. The walls are just about 3/4 of their final height, and then there'll be a wedge that goes between the two walls that forms the upper rim of the leader holder. And here we have the final layers being printed. After it's done laying down material, then it has to cool down. Right now the bed is running at 110 degrees centigrade, and it has to cool down to about 50 before the item will release itself from the bed. So here's the completed print. This was printed at a fairly low resolution, so I'm not that concerned about surface characteristics. You can see there's obviously ridging on the top, on the sides, and the bottom's quite a bit smoother since the first layer is kind of mashed into the table to get good adherence. So this was printed with HIPS, high impact polystyrene. I like to use polystyrene because it's easy to work with both printing, and it's easy to finish, both sanding and painting if you should choose to. And it's reasonably strong, and although not UV stable, I've had a test article outside since mid-April with no obvious degradation over one summer, so it holds up reasonably well to UV. So the next step is to remove this outer layer that was supporting this shelf on top, and then I'll have my finished product. So here's the finished product after I took the support material off. All pretty simple, and I make my leaders always with a bead chain on the end that connects to my flashers, and then I use a ball bearing swivel and a dual lock on the lower end. And so to wrap this, I just put the bead chain through a slot here, wrap the line around. If I'm doing multiples, I just daisy chain all the leaders together. And typically I start the season with 5 of each of my lengths, and then when I get to the end I just put it through the nearest slot, and that keeps everything in place. And then I put these in Ziploc bags to keep them from get tangled together, and that's how I store my leaders. In terms of cost, the material cost to print this was about 60 cents, and probably a couple cents worth of power.